Hey everyone, now that I've learned how to find the area between the curve and the x-axis, it's time for us to find the area between the curve and the y-axis, alright? So between the curve and the vertical y-axis. It's actually the same as how you find the area between the curve and the x-axis, it's just that now it's the y-axis. So if you recall, right, when we find the area beneath find the area below the curve and between the x-axis, let's say from x equals to a to x equals to b. So let's give this function y equals to fx, and then obviously you put it in the variables for the x's. So we know that the area is simply just integrating from a to b fx dx, right? Because we are comparing the area between the curve and the x-axis, we have dx, and the function is in terms of x. If you're going to find the area between the curve and the y-axis instead, it's just the corresponding change. So let's say I have y equals to a to y equals to b. So integrating from a to b dy. Because we're integrating with respect to y, our function inside the integral must be also in terms of y. So we have this gy, and we label the graph instead x equals to gy, right? So this is basically the idea of finding the area between the curve and either axis, alright? You're going to find between the curve and the x-axis, it will be dx. If we're going to find the area between the curve and the y-axis, it's going to be dy. Subsequently, the functions in the integral must be in terms of the variable that you are integrating with respect to. As you can see, here is fx, a function in terms of x. Here is a function g in terms of y. So let's put that into an example. So let's say I'm going to ask you to find the area between the curve, alright, and the y-axis. So how they will frame the question is, you have a curve, y equals to x plus 1. Find the area between the values y equals to 1 and y equals to 2. So first thought will be, well, I integrate from 1 to 2, so I must get a function in terms of y, right? So in this case, x will be y minus 1. So I'll be integrating y minus 1. So just to put it here, alright, dy. So what you should be doing is draw the graph, right? So y equals x plus 1 is simply like this, alright? How you do it? Very simple. Put s equals to 0 first. So s equals 0, y equals to 1. So at this point here, y equals to 1. So you know that the area from 1 to 2 is basically just on the right of the y-axis, which is actually the positive, right? X and y are both positive, so the area must be positive. So this is the area that you want, it's a triangle, all right? So what I do, now that I've confirmed that the area is positive, you just need to integrate directly. There's no negative area, so there's no need to split, there's no need to add any more to the sign, there's no need to go and flip the variables, the limits around. So just perform your basic integration. So increase the power by 1 and then divide by the new power, limits to 1. Sub in your limit, so be careful with this. So sub in 2 first, I'll get 4 over 2 minus 2. Minus away, sub in 1, so I get half. Minus minus becomes plus, so it becomes plus 1. This will then give me half, right? Units square. So there's one way to check your work. Because you know that the area between the graph and the y-axis is a triangle, right? You notice this intersects the y-axis, and then this is a triangle because this graph is a straight line, y equals to x plus 1. So you can kind of like work it out, you know, by brute forcing it lah, right? So you know that you're finding between y equals to 1 and y equals to 2, so the height here must be 1. At this point it will be x equals to 0. At this point when y equals to 2, x is 1, so 1. So you know that the horizontal width is 1, so 1 times 1 is 1 times half, because, you know, taking area of a triangle is half base times height, so you get back half. So this is the correct area. Is this the only way to find the area between the curve and the y-axis? Answer is no. Alright, there's actually another way of doing it. So if I draw the same graph, right, so this is again 1 and then 2, right? So this is the area we want. If I had to just draw it downwards, what do you notice? I get a rectangle, right? This rectangle down here. What you can do is, instead of finding the area between the curve and the y-axis, you compute the area between the curve and the x-axis instead. Just that you need to take the area of this rectangle minus away this area down here, which is happens to be the area between the curve and the x-axis. So you know that when y equals to 2, x equals to 1, so you know that the width is 1, the height is 2, so you know that the area of the rectangle is 2, minus away integrating from 0 to 1, because you're now integrating respect to x, right? Because the area between the curve and the x-axis is dx, so it's simply x plus 1, right? So you can say y equals x plus 1 here. Again, performing your basic integration, 2 minus x squared over 2 plus x. Now, be careful of your limits, it's now 1, 0 to 1. Substitute your limits inside. This is basically 2 minus half minus 1, because minus, minus outside, so both inside will become, at the end, become minus. This will also give you back half units square. So there are a few ways to do it. One is considering the rectangle, and then you're minusing off the area underneath the graph between the curve and the x-axis. Otherwise, you can just directly integrate it. Although the second method of considering a rectangle seems to be a more common method, because some of the graphs, right, you can't really find a proper function in terms of y. For example, if a y equals to, let's say, a cubic function, x cubed plus x squared plus x plus 1, good luck to you. It's extremely difficult to find a function in terms of y. So sometimes the rectangle method is better. All right. So yeah, there we have it. Two methods to find the area between the curve and the y-axis. One is the direct integration, if you can find a function in terms of y. The other is basically taking a rectangle and subtracting the area between the curve and the x-axis.